All right, let's talk about building on AWS. Everyone wants to design the perfect system, right? But here's the secret. There's really no such thing as a single perfect design. It's all about making a series of really smart trade-offs. Okay, let's get into it.
So, this is the big question, isn't it? When you're designing something in the cloud, you're always juggling these four things. You want it to be cheap, you want it to be fast, you want it to be powerful, and you want it to be super reliable. But here's the catch, and this is the key to everything. Pushing hard on one of these almost always means you have to give something up on another. So in this explainer, we're going to break down that balancing act and give you the framework to make the right call for your project.
All right, let's kick things off with the one everybody's boss asks about first, cost. Now, the goal here isn't just about being cheap, It's really about being efficient. It's about hunting down and eliminating any waste, so you're only paying for the exact resources you're using and not a single cent more.
The good news is AWS gives you this whole toolbox to slash your bill. And the number one principle? Kill idle costs. Seriously, think about something like Lambda. You're not paying for a server to just sit there waiting. You pay for the literal milliseconds that your code is actually running. The same idea applies to grabbing super cheap spot instances for jobs that can be interrupted, or even just telling your test environments to shut down at night.
And here's how you can combine these in the real world. Let's say you're building a static website. You just store your files in a super cheap S3 storage class. Then you let CloudFront cache those files all over the planet, which is way faster for users and saves you money. And if you need any simple logic, you run it right at the edge with Lambda. The end result? A global, super scalable website that might only cost you a few bucks a month. It's pretty incredible.
Okay, so we've covered saving money. Now let's flip the script and talk about raw speed and power. High performance is all about throughput. Basically, how much heavy lifting can your system actually do in a set amount of time? This is for those really demanding applications.
And to get that kind of performance, you got to pull out some specialized tools. For apps that need to chat with each other with almost zero network delay, you use something called placement groups. For a database that's getting hammered with reads and writes, you provision these blazing fast IO2 EBS volumes. Think of them like SSDs on steroids. And of course, to handle those sudden floods of traffic, auto-scaling is your absolute best friend, spinning up more servers when you need them and getting rid of them when you don't.
A gaming backend is a perfect example of this. You've got a powerhouse database like DynamoDB Global Tables handling millions of player actions from all over the world. But for that pure, instant speed, you slap a DAX in-memory cache right in front of it. That's your secret weapon. It serves up the most requested data in microseconds. That combo is how you get that seamless, real-time experience that gamers demand.
Now this is a big one. You might hear performance and latency and think they're the same thing, but they're not. There's a really crucial difference. Performance is about how fast your server can think. Latency is about how long it takes for the answer to travel to the user. This is all about closing that gap.
So how do you fight latency? Well, the number one rule is incredibly simple. Reduce the distance. You have to get your data and your application physically closer to your users. That's exactly what services like CloudFront are for. They stash copies of your content in cities all around the globe. Global Accelerator does a similar thing for your app traffic, finding the absolute fastest network path from the user to your server. It's all about cutting down that round-trip time.
Just think about a video streaming app. You store the main video file in S3. But when a user in, say, Tokyo wants to watch it on their phone, a Lambda function can kick off a job to create the perfect version for them, and then CloudFront delivers it from an edge server right there in Japan. That's how you get videos to start playing instantly, with zero buffering.
Okay, our final pillar is resilience. And this one starts with a totally different mindset. You have to just accept that things will fail. It's a fact. Servers crash, networks have hiccups, entire data centers can go offline. A truly resilient architecture is one that just assumes this will happen and is built to survive it without breaking a sweat. You do this with two magic words, redundancy and decoupling. For instance, you run your servers in multiple isolated data centers, what AWS calls availability zones, or AZs. So if one AZ has a problem, your load balancer just automatically sends all the traffic to the healthy ones. And you use services like SQS,
a message queue to separate parts of your application. So if your order processing system slows down, it doesn't bring your entire storefront to a grinding halt.
An e-commerce site is the perfect case for this because downtime literally equals lost money, so the architecture reflects that. You have web servers spread across multiple AZs with a load balancer out front. The database has a live backup copy in another AZ just waiting to take over instantly, and for true worst-case scenario disaster recovery, you're even copying critical data to a totally different AWS region hundreds of miles away.
Okay, so we've looked at cost, performance, latency, and resilience, each in its own bubble. But now for the most important part of this whole explainer, bringing it all together.
You've seen the tools, you know the patterns, so you can just build a system that's ultra cheap, lightning fast, has zero latency, and can survive a meteor strike, right? Well, not so fast.
And this is where the balancing act comes in. Every single decision has a trade-off. If you chase that super low cost with serverless, you might introduce a tiny bit of latency. You want that high-performance database? It's going to be more expensive and probably more complex to manage. And building that unbelievably resilient, multi-region architecture? Well, that's going to have a big impact on your monthly bill and your team's workload. This is the core challenge of being an architect, deciding which of these trade-offs you are willing to make for your specific project.
Now, the good news is you don't have to figure all this out on your own. AWS has formalized this entire way of thinking into something called the Well-Architected Framework. It's basically a guide to help you ask the right questions about these very trade-offs we've discussed, plus other critical things like security and operations, so you can build a system that actually meets your business goals.
So let's do a quick fire recap. If your number one priority is cost, you need to embrace serverless and automate everything you possibly can to just eliminate waste. If you need raw, brute force power and throughput, the modern cloud way is to scale horizontally. Don't build one giant server. Build lots of smaller ones that work together.
To crush latency and make your app feel instantaneous, you have to find ways to reduce the physical distance. Get your data and your compute power closer to your users at the edge.
And finally, for resilience, you have to adopt the mindset that failure is not just possible, it's inevitable. Design your system from day one to detect it, withstand it, and recover from it automatically.
And that brings us to the end. So as you think about your next project, which pillar will you choose to master? Will you prioritize low cost, raw performance, low latency, or that unbreakable resilience? Because choosing where to focus, that's the first and most important step in great architecture. Thanks for watching.